In this session, I'm going to talk about two other important aspects of R, wherein we are looking at matrices and arrays. What is the key difference between them, and how do we really get into the manipulation of the matrices and arrays? So, whenever we are talking of an array, it's a multi-dimensional object. If it is single dimension, we are calling it as a vector. So anything that is multi-dimensional, we are calling it as an array. And how many dimensions are there? We are specifying by the dim attribute present as a part of the array. So simple thing. Let me take a series of numbers. Right? Let me take a sequence of numbers x. Let me take them 1 to 24. Right? So I have 1 to 24 as my numbers. Now on the top of them, I am giving a dimension. I am defining the dimension of x, saying it is 2 comma, I am using a concatenate operator, 2 comma 4 comma 3. So it means that 2 rows, 4 columns. Right? What does this mean? 2 rows. The multi-dimension here is 2 rows, 4 columns, and 3 such kind of arrays are created. Now, if you look at x, now this is what I meant to say. There are 3 dimensions. First dimension, second, and third. And 2 rows in each of them, 4 columns, and the numbers 1 to 24 got allotted like this. By default, the allotment will be column wise. So 1, 2, 3, 4, 5, 6, 7, 8 is in the first dimension, 9 to 16 is in the second, and 17 to 24 is in the third. Now the same thing, probably if I am changing the dimension of x to 2 comma 4 comma 2 comma 3 comma 4. Now what is the change? 2 rows, 3 columns, but 4 such dimensions are created. 2 rows, 3 columns, but 4 dimensions are created. Now that is how we express the array here. We are having multiple dimensions. Right? So when I am writing it as C of 2 comma 4 comma 3, I am talking of 3 different dimensions, 3 two-dimensional tables which contain 2 rows and 4 columns. And we need to understand that matrix is a special case of an array where we have only 2-dimensional stuff. It's a 2-dimensional array containing only numbers. That is what we are calling as a matrix. Whereas there is another data type in R called as a data frame. Even that is also a 2-dimensional array only. But the thing is, it can contain numbers, text, logical variables, each in different column. In each column, it has to be the same. Right? If I am talking of column 1, it has to be all numbers or all text like that. But column 1 could be numbers, column 2 could be text, and so on. Whereas when I am talking of matrices, everything should be a number only. It can't be a text. So these are some of the variations in terms of matrices and data frames which come under the broad heading of arrays. So whatever we are representing, the first one is talking about the row, the second one is talking about the column. So whenever we are trying to pull out, okay, now the same, let's say I'm pulling these into a matrix. It means that if I'm making dimension of x, right, if I'm setting the dimension of x as 4 comma 6, so in that case x is like a matrix. Right, the same 1 to 24, I am making it in 2 dimensions. This is getting as a matrix. So if I do a class of X, here it is showing it's a matrix because any array of 2 dimensions is what is called as a matrix. Now I want to extract, right? Out of this X, I want to extract something colon 3, something comma 3. Means if there is a blank, it means all the rows of the third column. Third column, all the rows. So I'll get 9, 10, 11, 12. Whereas if I say X 4 comma blank, then I'll get fourth row all columns. Fourth row all columns 4, 8, 12, 16, 20, 24. Then if I say X, let's say the row number 1 comma 3, right? And the column numbers 3 comma 5. This is what I want. Then it is telling me the row number 1 comma 3, right? The first row and the third row. This is my first row. This is my third row. Out of these two, I'm getting the third column and the fifth column, which is 9 and 11, 17 and 19. So I can very well extract any subset of my matrix using the subscripts that we have used even in case of vectors as well. So the matrices typically, okay, I can define this matrix using the dimension like this, or I can simply say matrix, yeah. I can very well say matrix of X matrix of X, comma, the number of rows, I can say n row equal to 4. So by default, the columns are computed. So the X is created as a matrix, right? If I want to change matrix X n row equal to 8, then it means 8 rows, 3 columns are typically computed for this matrix. So when I say X now, okay, because my X initially got allotted to this, but whenever I'm saying X, you express it in terms of n row equal to 8, I'll get it like this, n row equal to 4 comes like this. Now if I am allotting it to another variable, that is what will be my updated matrix. So the class of it we have already checked, it will be showing the matrix, right? And if I say attributes, right, attributes of X, so this is what will give me the dimension of the matrix. So it's 4 rows, 6 columns. So if I want to get the dimension of the matrix, I can simply say attributes of X, right? Now we have already said that by default the numbers, the X was right, we have simply said X is something like this. Dim of X, we have made it 4 to 6, right? The initially X was these values 1 to 24. Now if I make this X, so again let me do an allocation of X 1 to 24. Now when I simply type X, I'll get something like this. Let's say I simply make matrix of X, comma, n row equal to 4. Now I'll get this as the matrix, 4 by 6 kind of a matrix. And you see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they are filled in the columns. Whereas if I want them to be filled by rows, this is where I can use by row equal to true. Now the same thing, if I add one more variable or one more parameter saying by row equal to true, it means that the allotment of the numbers 1, 2, 3, 4 up to 24 is happening row wise, not by column wise. So the default behavior is whatever is the sequence that gets added column wise, Whereas when I'm saying by row, whatever is the default, whatever is the sequence that gets added row wise. And if I really want to find out the dimension of the matrix, I can simply say dim of x. Right now I didn't know x is 1 to 24. So let me allot x, which is the matrix of x comma n row equal to 4 by row equal to true. Let me allot this matrix. Now I can very well find out the dim of x, which is 4 comma 6. Now probably if I want, I can very well check whether this is a matrix or not by using is dot matrix of x. It says it is true. And now I can also do a transpose. Transpose is nothing but the rows become columns and columns becomes rows. So I'll create a new matrix y where I'm saying t of x. T is a function that is associated with the transpose. So now if I display y, I get the rows transposed as columns and the columns becoming the rows. So that is what we are calling as the transpose of a matrix, which is represented by T, right? And if I want to give some kind of names, right? So I can very well give the names to the rows. So let me give row names, right? I'll give the row names to x. I'll give the, instead of 1, 2, 3, 4, 5, 6, I want to give the row names to x. If I want to give some names, let's say, let me give them A, B, C, because there are 6 rows. Oh, sorry. Yeah, the x actually has 4 rows. This is only the transpose of x, which is y. So because x has 4 rows, I am saying row names of x is A, B, C, D. So this becomes x is showing A, B, C, D here as the row name. Similarly, I can give call names of x. I can give the column names to x. Right, probably I'll call them as U, V, W, X, Y, and Z. I'm simply giving these as the column names. Okay, I have to enclose them with a C function. So now when I display X, I get the row names as A, B, C, D and column names as U, V, W, X, Y, Z. So I can get the row names, I can get the column names, I can assign any of them to the matrix. Now comes the next aspect, where I'm doing some kind of calculation. Now let's say I want to find out the mean of the 5th column values, all the rows, right? So simply I'm trying to find out the mean. First of all, let's see x of, if I'm simply taking x of dash the blank comma 5, which means all rows 5th column. All rows 5th column, these are the numbers that are coming. On the top of it, I will put a sum, or I'll put an average, mean, whatever it is. I'll put a mean on the top of this. This is the best way to write the formulas. So I'll get the mean of this saying 40. The same way, if I want to get everything from the 4th row, so first let me extract the numbers, right? Let me extract the 2nd and 3rd rows, all columns. So when I extract 2nd and 3rd rows, all columns, these are the things that are coming out. So I will take the sum of all those things. So I'll get this values. On the top of this, I'm simply getting the sum of all these values. So it says when I add up all these values, the sum is coming out to 150. So this guy. And we have few more interesting functions. Row sums. If I really want the row sums, I'll say row sums of x. So all the rows will be summed up. So the first row sums up to 21, the second row sums up to 57, and so on. Similarly, I can use call sums. Call sums, I can allot them to any other variables also. I'm just computing them. So you will get the column sums. Similarly, row means of x, call means of x. Different kinds of summaries are also coming up for us. Then, the other important thing is, this is also another way of computing the column sum. In this, there is a apply as a function that I am using. So this is same as if I'm simply saying if I have to do a row sum, the other way is use the apply function, apply x, comma, if I put 1, it means the row related, 2, it means the column related. Then I have to specify what is the function I want. So if I say sum, it will do the summation of the rows. So it gives me the row sum. But if instead of sum, I put mean, it will do the average of the rows. Similarly, instead of 1, if I put 2, it will do for the columns. It will give me the average of the columns. So that's the way this apply as a formula is working out. Now, let's say I want to group, right? So I'll create one group, probably, right? I want to create a group like this. So I have to do a row sum, but only of, I'll create a group like first and the fourth are one group. So I'll create a group which is saying some group A, probably B, then the third one I am creating it as A, the fourth one I am creating it as a B. So a group actually contains A, B, A, B. Now I want to find the rows, probably row means or row sum, right? I want to do a row sum, not just of x, but based on the group. So I want to do the summation of the rows separately for each group. Sorry, it's not row sums, it's a row sum. A row sum of x based on the group. So for each row, the summation would be done separately. The first and the third are a part of the group. So the rows 1 and 3 will be added. So 1 plus 13, 14. 2 plus 14, 16. So A is nothing but rows 1 and 3. They are added together. B is nothing but rows 2 and 4. They are added together. So that is how we are getting group wise kind of totals also. Now, another couple of functions that can really play an important role is, right, I have found out the mean. Now I want to append that as a new row, right? I have found out the column means. I want to append those column means to the existing. So right now I have my database like this, right? 1, 2, 3, 4, 5, 6. My matrix is like this: 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now here I want to add one more new row where I am computing the average of each of the columns, right? So this is where what I can do is I am doing a row binding. So I'll say row bind, r bind, where I am using the data as it is, which is x, comma, I have done the call means. The call means of x I can very well do, or I can use the apply function, whatever it is. So I have binded So I'll get it as 1, 7. So for the averages I'm getting here. Similarly, I can say C bind. I can do a column bind. Again X, and whatever are the row means that are there of X, I can add them as a column bind. So I'm getting all my row means here. So again, it's better that I associate X to this, right? So this new one, I'll simply associate X. So now my X is containing all this. Now for this I'll do a row bind. So I'll take the row bind of X and call means. So I'm finding out the row bind of X along with the column mean. Now if required, I can very well even allot some kind of names to the final values, but at the end you are seeing that these are the means that are coming up. These are the means that are coming up. If I don't want the means and I want to compute the variances or something, then it's better that I use apply rather than using the row means or the column means, something. Now I can even, if required, I can even put the naming. So I can say names of, so I can even give the namings to each of the rows if required. Otherwise I can simply go ahead with the computation as it is itself. Okay, so we'll do these kind of calculations. So let's say we are doing these kind of calculations and adding up to our data. Then now that we have computed the column means, right? We know that these are the column means. Now what I really want to have is, I really want to find out what is the difference of each of the values from the column means, right? Now that is the one I can very well accomplish using the sweep function, where I'm looking at the each column, how much is it changing from the column means. So I'll use sweep within my X, and I want to look at the columns, to what extent they are differing from the column means. So let's say I have found out the column means of X, or I can use the apply function also. So what it says is the column means for each of the observation, I am trying out the difference between the observation and the column mean. 1 minus 10, minus 9, minus 9, so on. Similarly, if I am using the sweep function on X, each row, how much is it differing from the row means of X? Now that is what will be given through my sweep function. So what it is doing for each X, so for each observation, it will subtract the row mean. 1 minus 3.5 gives minus 2.5 and so on. So that's how I can find out, I can use the sweep function. So the sweep can be used on vectors, matrices, anything, which is basically whatever is the computation. See, I don't need only the mean or whatever. Let's say I'm saying sweep, right? I'm saying sweep. Let's say I want to subtract every element, every column value, right? Every column value, I want to subtract 5 from it. Then also you could see there is a 5 that is subtracted from each of the column values. I am looking at subtracting 5 from it. Right, so probably 1 minus 5 is minus 4. 7 minus 5 is 2, 8 minus 5 is 3. So I can use the sweep function to even do this kind of a job for me, right? Or I can subtract different elements. So probably I can say sweep x comma 2 from each column. I'll subtract so a different number 1, 2, 3, 4, 5, 6. So from the first one I want to subtract 1. The second one I want to subtract 2. Right? What happened? Stats. Okay, there is a subtraction that is done. So 0, 0, 0, 0, 0 because 1 is subtracted from 1. The second is 2 is subtracted from here. Now similarly, then we have from the second again 2 is subtracted. So here 1 is subtracted, here 2 is subtracted, here 3, here 4, here 5, here 6. So different numbers are subtracted from different columns. So that's where we are getting a different set of numbers altogether. Now these kind of computations can very well be accomplished through different sweep functions which I am using. Now the other thing is apply. We have already discussed about using apply. Right? Apply on a particular data, whether it is rows or columns. 1 means rows, 2 means columns. And what is that I want to apply? So I can apply a sum, I can apply a square root or any other function. So this is applying on the matrix altogether. Right? When I am saying apply, right, probably let me define x again specifically. Right, x, I am saying matrix, or probably x, let me first put it 1 to 24. Right, and again I am defining x as matrix of x, n row equal to 4, n row equal to 4, which is telling me that my x is a matrix like this. Now in this I want to apply x comma 1 comma mean. Means I'll do a row means. So this means the row means are typically computed. Row means are 11, 12, 13 and 14. Right? So it is applying on the entire matrix. Whereas when I am using yes apply, it is for any function we are applying to a specific vector. Right, especially when we are using complicated iterative calculations, I really will use s apply because I am using the function to each of the vectors separately. Right, so that's one more thing that we are typically using. Then I want to find out the maximum column. Right, I want to find out which actually has the maximum value. So let me find out max.call of x. Oh, sorry, not call. Max. Sorry. Max. I want to find out the maximum column. So I'll say max.call of x. So it's saying the maximum in each of the columns. All the row. So what is it saying? Which row has the maximum value for each of the column? So for column 1, which row has the maximum value? The 4th row. For column 2, which row has the maximum value? Again the 6th row. Right? So I mean which row has for each column, right? Or for each row, which column has the maximum value. Here the sixth column has the maximum value. Probably the better way is, let me take X as runif 24. That's the easier way. I'll take some random values and X I am assigning matrix of X n row equal to 4. Now we'll have different kinds of maximums and minimums. So I'll say max dot call of X. So now look at it. First row. What is the maximum value? This is the maximum value in the first row. So the sixth element is the maximum. Right? It's maximum column. The column that contains the maximum value in the first row is the sixth column. The element that contains the maximum value in the second row is the first column. The element that contains the maximum in the third row is the fourth column, and the element that contains the maximum in the fourth row is the sixth column. That is what is max.call giving. And I can also get whatever is the max.call, I can really get whatever the values that are associated, or probably I can even extract the max.row, which is, okay, for each of the rows I can't get it, but for columns I am getting the maximum value for each of the column, for each of the rows, which column contains the maximum value for each row. So that kind of thing I can very well extract using the max.call kind of a column. Then, yeah, this is an interesting thing. Let's say I have a multi-dimensional array, right? Like let's say initially we started off, let's say this is the same X. Right now, X, let me take it as runif 1 to 24, runif 24. I'm taking some random numbers and I'm saying dim of X is C234. So from here, if I am looking at X, this is what I am getting. 4 two-dimensional arrays of 2 rows and 3 columns. Now, if I just want to change it, saying if I really want to change it to a new data, I'll use a perm. So basically, it's like I want to retransform it. So the first should be this one, the next should be this one, and the next should be this one. So I want to just change this into a 2 different 3 by 4 kind of dimension. Then what is that I am saying? New X is some variable that I am defining, where I am using APERM on the same X, where I am changing the order. Okay, I want the second one first, so I'll put the second one, which is this dimension first. Then I want, let's say, this dimension, or this dimension I want second, so that's where I'll put 3, and finally I want this dimension. So I want it to be changed to this. In that case, now let's see what is coming out with new X. So because the first is coming out as the second of the original. Second of the original is 3 rows. Third of the original is 4 columns. First of the original is the third dimension containing 2. That's the reason the values are getting retranslated using the APERM kind of a notation. APERM is actually changing the restructuring of a multi-dimensional array. So these are the different kinds of calculations that you can perform on the matrices, on the arrays, which is another important aspect that we need to be comfortable with when we are executing different different calculations for different domains in R. If you have any further queries, you can get back to me by giving me a call on the number that I have provided below, or you can send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.